Welcome to the Twinstar II how-to video, and today we are going to learn how to build the Twinstar II electric almost ready to fly plane, which requires approximately 4 to 6 hours of building
the box that the kit comes with. This is the Twinstar II, exceptional aircraft rated highly by many RC flyers out there. We'll take a look at what comes with the base kit. Now this tutorial is going to cover the basics of doing a brushless upgrade with litho-poly batteries, but we'll take a look at what comes with the kit. With the kit, you get the user manual, you get all the decals, your Eliper foam, highly rated foam, very strong, very durable. There's the main fuselage section there, tail section, elevator, canopy part that snaps on. With the kit, they automatically give you two 400 speed brushed motors along with two propellers. They appear to be, I forget the exact dimension here, they are 125 by 110s. I think that's in millimeters. It's like 5 by 5 roughly. And they give you a motor harness, goes in the nacelles. There's two of these. I'll be using these later on. And some wiring components. Motor connector. And they give you the rods and the various linkage control arms and so forth that'll need cut later on, as you'll see. What would be helpful is to also have the servos. Here you can see two of the 4 HS81s and a receiver, of course. In my case, I got an Electron 6 micro receiver. It's a dual range, or dual conversion, I'm sorry, receiver capable of longer distances as far as range goes. You always want to make sure you get a dual conversion. This one's a negative shift because I have a Futaba that needs a negative shift Futaba transmitter. And the wiring harness for the ESC and the servo extensions to reach the rear servos. Accessory pack for the various connector tools and parts. That comes with the kit by default. The pack of tools does. So in addition, you'll have to buy the servos, you'll have to buy the receiver, you'll have to buy the servo extensions. In this case, I think I got 12-inch servo extensions, 2 of them, and the Y harness. Those are all extra. You also have to buy CA glue, the stuff that is not foam safe. In other words, as long as it doesn't say this is foam safe, you should get it, because you don't need foam safe for this type of material. And you need the accelerant, CA accelerant, and a low temperature glue gun, and the glue sticks. And what will be useful later on is a tachometer and a watt meter. Those aren't required, but that's useful in fine-tuning the motor performance. Of course, a pair of wire cutters always comes in handy. You need a hobby knife to cut some of the foam, pair of scissors, and a ruler for cutting the lengths, which are in the manual in millimeters. Here's some of the stats on the Twinstar II. The wingspan is 56 inches, the fuselage length is 43 inches, the wing area is approximately 4.7 square feet, the weight is approximately 53 ounces, fully loaded, and that's with a NiCad 8-cell battery pack and the 400 speed brushed motors. Now we're going to be doing a brushless LiPo setup, and it should come in around 43 ounces once the LiPo batteries are installed. The wing loading is 11.5 ounces per square feet, and that's that. We're not going to do the painting first. We'll save that for last, and we will get started right after this. One of the first steps involved in putting the plane together is putting the control rods and sleeves in the fuselage. Instructions say to cut the elevator, rudder, aerial rods, but they appear to already be cut. In fact, one of them wasn't even the right length, but everything appears to match up with the diagrams. So left fuselage. The first step you do is fit the elevator snake 41, 45, and 43, and the steel rod of 770 millimeters, the longest one, in the left-hand fuselage shell. And you put the hook, the preformed end, up towards the nose. You want the tubing to go flush right where my finger is, and the inner tubing to come out just a bit like that. And that goes down through the fuselage, that's the left side, through a little hole, and then back onto the outside here. There's a pre-made groove on the outside for that, and then back here is the steel rod, which we'll use later on to connect to the horn in the back. On this side, it's the same deal. I'm going to make sure that fuselage, that the tubing in the fuselage is flush here, the outer tubing, and the inner tubing comes to about there, and then there's the control rod going down through the fuselage and then out the back, and this is normal to have the tubing here, as you see. The next step in this part will be to use some CA glue to glue the tubing in the channel, and I'm going to do that next on both sides. Okay, so resuming here, I've used the CA glue. Here's the glue again, Superjet and the jet setter. The accelerant, basically we spray on the accelerant to one side, wait about 2 minutes, and then use the jet set CA glue, medium CA glue, on the other side of the surface. So what I did was I used the spray and I sprayed it in the channel, and then I took the CA glue and I put it in the channel as well, because that's technically the other side, and I pushed the tubing down in using the scissors as a guide, and it dries very quickly within 60 seconds, so you got to work quickly. So I did it on the fuselage on both sides, inside, and then I did it, came to the outside and did the outside channel as well. One other note is to make sure that the glue does not get near the steel rod which comes out of the tubing, because if it does, obviously that will jam things up and cause a big problem. So please take care in that regard. Next step is installing the wing retainer plates 33 and 34 in the manual. What we're going to do is take these two plates and we're going to glue them together with a little CA glue, and then we're going to insert them right into the fuselage, as you can see in the manual, or more aptly here on the left hand side of the fuselage, here and here with some CA glue. We're going to finish the CA gluing of the wing retainer screw plates. Getting them together was a bit tricky. I highly recommend using a pair of pliers after you apply the accelerant to one side and the CA to the other. Use a pair of pliers to grip them together. Next I'll install them in the fuselage. Okay, I've completed gluing in the wing retainer screw plates on the left wing panel. If the plane is facing you, that would be the left side. As you can see, they're glued in place using the CA and the accelerant. The next step will be installing the canopy latch system on each side of the fuselage. I've already laid the pieces in their place, but if we can come in close here, you'll see how we put the pieces into the slot. I'll take this one out here so you can see a better view. Put it in with this side flush, so that it sticking out of the slot slightly. That way the tongues, which will be installed into the canopy later on, as you'll see here. That's not fully installed, that's just to give you an idea of what's going on here. We'll have two tongues, one on each side there, the other one's not there yet. And they'll get latched down into the fuselage latch system, keeping the canopy on nice and tight. So next step is to take some activator spray the fuselage, and then put some glue on the back of these latches and put them in their spots as quickly as possible, because it will dry very fast. So I'm going to do that right now. It's installing the servos in the fuselage, and for that part the manual recommends that you set them to the neutral position by turning on the transmitter and plugging them into the receiver. Well, at this point I'm not quite ready for that, so we'll worry about that later, which you can do later on. As you can see, you can still get in there and unscrew it if you need to set it to the neutral position. So we preset them into the notches, feed the wire down through this channel right here on both sides, and in a minute I'm going to take some hot glue and we're going to put some hot glue here, here, and along the wire lead to keep it in place. Same thing over here. Now for the wire lead you can also use 5-minute epoxy if you wish. So we'll fire up the hot glue gun and put in some glue sticks in 1 moment. Again, this is a low temperature glue gun. I've turned it on for a few minutes and I've stuck the glue stick into the glue gun, and you simply pull the trigger as it feeds it in. And it's ready to go. Fully loaded. You can get one of these glue guns at Michael's craft store, any craft store. They're about $2, and the glue sticks are like $3. Very inexpensive, and this is a low temperature glue gun. So now we're ready to apply the hot glue to the joints and to the wire lead. Get it in there nice and good on the joint where the screw would go. I also put a little along the crease there and a little on that crease there to make it nice and secure. I'll do the same process on the other one and on the wire lead. I won't videotape that process because it's fairly straightforward. Alright, we're now at the part of the video where we are supposed to, via the instructions, to spray CA on this side of the fuselage, or I'm sorry, spray the accelerant on this side of the fuselage, wait a few minutes, and then put the CA on all the joints on this side and carefully put them together, but quickly. Now, this only has a one-shot type of deal, so if you screw up, you're out of luck. So you gotta act quickly once you put the CA on the side that you're putting the CA on. However, prior to doing this, I'm going to actually work ahead to make it easier. I'm going to remove some foam here, right there. I'm going to remove that chunk of foam. And I'm also going to remove this chunk of foam right here. The reason, you might ask? Well, that is so we can have access to these extra channels back here. In fact, I'll remove this foam as well, and that foam. So that gives you more room to put instrumentation inside the plane later on if you decide. As you'll see in other installments, I'm actually going to put 900 megahertz or 2.4 gigahertz depending which we decide to go with, camera equipment on the plane, and some of that equipment can be stowed away and adjust the center of gravity as needed. better if the foam is removed. In fact, there may come a point where we may need to remove some of the foam from the front of the nose if we need to shift the battery further forward. That's all later on, but for right now, to make it easy, because once they're fused together, we won't have a choice. We're going to remove the foam now. This is just to give you an idea of how we chop away at the foam to remove it. Using the foam is pretty straightforward, but just to show you how we do it. Using the hobby knife, I've just made slices through the area I want to remove. Cut around the lower edges as well, cutting flush with the surface. So now, if I keep chopping away, it'll eventually just flake off. Like so. Something like that. I'll fine-tune that, of course, but you get the idea. So I've finished removing all the foam to allow access to the back compartments in case we need it later on. As you can see, the foam is now gone, and voila! It's also a good idea to know the size and dimensions of your LiPo battery. In this case, we're using the LiPo batteries. Make sure they'll be able to fit properly so you can trim before you fuse the fuselages together. And I know my dimensions. In my case, I'm going with a 3200 20C 3S LiPo pack. Its dimensions are approximately 0.76 inches in thickness, 5.31 inches in length, and 1.77 inches tall. And that fits just about right in the front of the compartment if that's where it ends up going. We'll have to see where the center of gravity works things out to later on. So now I'm going to apply the accelerant to one side of the fuselage and then the CA to the other after waiting 2 minutes. I will then join the two together. Before I do any of that though, I'm going to do a test fit just to make sure everything works. Prior to doing the fuselage, I should mention that before we do that, we have to take number 47 aerial tube and glue it right there in that little channel along the edge of the fuselage. For that job I will use hot glue, and as you can see up here where I'm pointing with the aerial, that's where the receiver antenna will come down through the tube and out the tail, I believe, later on. It's also important to note that when you join the fuselage together, that there should not be any bends to it. It should be perfectly straight. Okay, now you can see I've gone ahead and glued the antenna tubing. Started off with hot glue, but ended up just using CA and accelerant the whole way. It was easier. And that was kind of hard to keep in place. But it's in place now, and now we're ready to glue the halves. This is a primary reason why you should do a test fit first. The screw holes here are not quite right. This one here is perfect. This one is off just slightly. Now I don't think that's going to be a huge problem because I think we can probably chip away at some of the foam if the screw has a problem fitting in there later on. But it's worth noting now in case later on we have a huge problem. But we'll see how it turns out. I'm going to go ahead and do the CA of the fuselage. And there we have the finished product of gluing it together. There's the fuselage with my one window markered in for a reference point from before. All set to go for the next part. Involves attaching the horn to the rudder. Here you can see the horn. It's going to go right inside of this groove right here. Loosen the parts here, as you can see. Very small, so take care not to lose them. These are the parts that will go into the outermost hole of the horn. And that's the Allen key to help get that little black guy into the silver part, which is number 28, I believe. or 25, I'm sorry, that's number 25, push rod connector. That is the push rod connector, that silver guy, and here's a better view of the diagram in the manual. And that's basically what I'm going to do, applying CA to the rudder horn after I've connected all these other parts. You also need to apply some CA to the washer nut once you're sure that the connector revolves smoothly but without wobbling, using the tip of a pin to apply it to the nut, keep it from coming loose. Place the connector through the outermost horn position, and then we take the washer, put that around there, and we have the washer on there, as you can see. Now I'll take the nut, and this is not hard to see here, screwing the nut on now. There, nut is on, connector is on, and we place the small grub screw inside with the Allen key. Grub screw is in there. Take the Allen key here, tighten that guy in. Like so. I have the grub screw fully in using the Allen key now. Now I'm going to tighten this guy up to the point where this connector piece at the top doesn't do this little wobbling thing. Like that, you see it doesn't wobble, so at this point I'll take the tip of something, like say this, some CA, and apply it to that nut right there to keep it from ever coming loose. And I will then apply some CA and accelerant into this part right here and attach this guy right like that. Got the same situation with the elevator horn. Same parts here. Going on in that orientation there in the outermost hole. And here's a close-up picture of that process. I'm not going to repeat this for the other two control surfaces because it's the same procedure in each one. The next part I've already gone ahead and done is I did the tail section, attached it to the elevator section first, once I had those two glued together and looking nice, and then went ahead, put the CA glue in the channel and made sure everything was fit, made sure the elevator was parallel with where the wings will be, and it wasn't that difficult. The hardest part was getting that tube right there out of the way when you were pushing the tail section in. Another thing they recommend you do is to move the control areas, surfaces, 10 to 15 times each to free them up initially. So I went ahead and did that with the rudder and the elevator. Alright, we're ready to move on here with the wing and aileron installations. Here we have one of the wing panels, as you can see. Now it comes from the production factory with these little winglets around the motor. We're going to need to cut those with a sharp knife. As you can see where my finger is, you'll cut right along here, 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 removing this wing piece. We will also need to make a cut down through here at 1 millimeter wide, basically the width of this little gap here, so that the aileron can move freely. And then we can move this up and down 10 to 15 times to get it loosened up, and we will repeat the process on both wings, and we'll move to the next step. Welcome back. We finished it up. I trimmed off the excess foam around the nacelles and freed up the wing, the aileron, so it can freely move now. Then to both panels. Ready to move on to the next step. The next step is gluing and installing the horns on the ailerons as before. Same procedure. Here's the angle that should be installed. Topmost hole. And there you can see the inclination. Same thing on the next step is installing the servo in the wing. As you can see here, we have an HS81. Take it back out here. Had to clip one side of it so that doesn't dig into the foam, obviously. And you should set the neutral position when the transmitter is turned on and it's plugged into the receiver. So my advice here is not to glue this in until you have the receiver working. Then you can go ahead and glue this into its spot, because otherwise you won't be able to get at the screw to adjust it. So we take a look here just to show you the fit. Fits perfectly right down in there. And when you do go to glue it, we will glue one drop down in there and one drop down in there per the instructions, and that will hold it in place. First we put the glue in, of course, and then we push the servo down in the hole. There's a channel here for the wing spar and the cables to go through. Obviously this cable is not long enough to reach to the receiver, and that's why we have the 12-inch extensions, which we'll be using shortly. I've also gone ahead and put the push rod into the horn outermost hole here, and I've screwed it into the grub screw. I loosened the grub screw in the back here with the Allen key, pushed it through. That'll need adjusted, of course, once the transmitter is turned on, the receiver is on, and so forth. There, as you can see, on the other wing, we have to make sure that this part is pointing inward towards the center of the wing, just like that one is pointing towards the center of the wing as well. And then we just connect up the control rod right there, and we'll glue that in later on. For this next step, we're going to get involved in the motor mount and our brushless upgrade. Here we're using Thunderbird 18 brushless controller. It has a 3 amp BEC, and in any of the Castle products it is safe to use dual ESCs with the BECs enabled. Consequently, you don't need the receiver battery pack. So those are perfectly safe and ready to go. They recommend you push the throttle all the way forward and hold it for 2 seconds, and then back down to the initial position before you fly. That sets it. And this is the extra 2829/10 brushless motor. I do not believe we'll be using this piece. We'll be using the existing motor mount. We'll get into that in a minute. There's the prop mount. And the props I chose here are 8x4 APC props. Very good props. You could go with a 7x5 as well. I chose the 8x4 to give more climbing ability for heavier camera equipment. 7x5 would give you better top speed, maybe less of an initial thrust to get up in the air. And we'll get started on installing the motor mount and the nacelle. Continuing with the motor mount here, we are using the stock motor tray and the piece that the stock motor attaches to. However, this one's a bit more difficult. With the extras, we have the propeller, which will be mounted out here on the front. The shaft comes out through the back. So in reality, this guy is actually going to sit right in there like that, slightly out towards the front, leaving enough room for this part where my thumb is to spin. The tricky part here was using the screws that came with the extra motor, not the ones that came with the stock mount. Put those down in those 2 holes there. You have to kind of juggle over that wire there, which will be interesting later on as we try to attach it to this guy. It'll basically get attached to this guy in this sort of position right there. And I'm going to do that next using the stock screws. And then we'll glue it in place with CA in the nacelle. Taking a look at the motor mount here, we use the stock motor mount on the stock inner tray. And there's only one way this goes on. You have to use the screws that come with the extra motors. You have to widen the holes up slightly using a screwdriver or a drill bit if you have one. And that is the proper orientation, either left with the wires or right with the wires. Otherwise you can't get at these screw holes very easily when mounting it into the tray, like you see there. Okay, so here's the completed motor mount. This is the proper way to mount the extra motor outrunner to the existing motor mount, the stock mount. Wires coming up at the left side. You can see which side I have here. And there's the screws that came with the extra motor. Those two black ones right there go in there. The stock screws for the mount are there, there, and then behind those wires there. As you can see, I've added a piece of black tape, electrical tape, just to make sure that that screw there doesn't happen to rub against the wire and cause a short. It was very tricky getting that screw in there. You had to be really careful and move really slowly without peeling off any of the wire. That's the mount. It'll get glued into the nacelle. Some trimming will be necessary either on the black mount or in the nacelle itself. I'll probably trim the nacelle and then put the black mount in and glue it in. I dug the nacelle out so we could fit the entire motor mount in there rather than cutting the motor mount. As you can see, it's pretty deep fit in there. Might have to adjust the center of gravity slightly. Looking at it from this angle, see if the can is spinning. It has a little bit of space below it, but I'm going to probably trim away at that to make that a little bit more comfortable so we don't rub. And I will later glue the motor mount in its place once we're sure of the positioning of the wires and the ESC. I've gone ahead and installed the prop mounts on the motors. These again are the extra 2829/10s made by Ripmax. Getting the prop mount on here was a little tricky. The screws didn't want to quite line up and it didn't want to stay flush unless you took each screw down evenly with the other one. But as you can see, it looks to be a fairly snug fit. The next step is putting the prop on, and the standard prop, as you can see, come from APC, is 0.375 inch diameter shaft, and that doesn't line up. So you have to use the included sample diameters inserts to get the right one. So you basically just go through them one by one until you find the right one. Also, don't want to forget to put the washer nut back on first, and then put the proper shaft insert on there, followed by the propeller, and then tighten the nut on the very end until it squeezes inside of the existing 0.375 inch diameter hole. You can either try to squeeze it on in that manner by doing it right onto the motor, but the easiest way might be just to take that insert, lay it on top, and take a screwdriver and tap it in its place. And there you see the proper fitting diameter. There we see the finished product. I've done doing some of the wiring on the ESC. As you can see here, I've went ahead and used the bullet connectors rather than directly soldering them and cutting the bullet connectors on the motor mount. I did this because it'll make it easy if you want to switch motors later on. You can easily pull these apart. Basically, you take one of these little tin cups, if you will, connectors, and you fill that little end there with solder. And I cut a little bit off of these ESCs here, the wires, to shorten them so there's not as much wiring in the nacelle. And then I soldered on the tin cup connectors, the bullet connectors. I went around and did it on both sides just to make sure it was a solid connection. And they're very solid, very little risk of them breaking off. And the heat shield will go right over top of those and over top of where they connect when they push together. I'm working on the second ESC right now, and I just wanted to show One of the keys to making those bullets work well is making sure that you trim off about a little less than a quarter, maybe about 3/16 of an inch from the tips. When you put them into the bullet connector, that makes a much stronger connection when they're shorter. Should also mention that when you're pre-tinning these or actually soldering the two together, take care not to overheat the wires too much, as it could affect the ESC itself, so limit the contact in brief periods of time. As you can see here, we have the battery leads coming off the ESC right here. Of course, these weren't long enough to make the required 300mm or about 4-inch extensions that are supposed to hang off of the wings. That's about 4 to 5 inches. So what I wanted was to make enough battery length so that I could actually run both ESCs off of the wings to a Dean's connector, which we'll put on here, and that'll hang loose and go into the airplane. And then inside of the airplane we'll have another Dean's connector on both sides, making a Y, and that single Y will go to a male connector, which will go and plug into the battery female Dean's connector. This will become more clear in the coming minutes here, but for right now the main goal again is to make a Y inside of the fuselage, and the long strand that goes to the male plug, which goes to the female plug of the battery, will have two pair for the positive and 2 pair for the negative going on to each prong of the male Dean's plug in the fuselage. It can be done, and as you'll see, it will be done momentarily. The length on these extensions, by the way, is approximately 9 inches to the point where it attaches to the existing ESC battery wires. There we can see the completed Dean's plug, male adapter. It'll go into our little Y cable. It'll be inside the fuselage. It's now complete. One little tip when you're using these heat shrinks around the Dean's adapter: if you touch them with the soldering iron, they will shrink up and tighten to the wire. Also very good to use is a 1/8 inch tip soldering iron, and 30 watts is what I've been using, and it's been fine. Should also note that in placing the engine, I have made it such that the blue, the very edge of the blue, should run just about parallel with the edge of the white on the cell when it's in its proper position. For right now, I'm not going to glue anything, even the wires, until we make sure that these cables are long enough. I've gone ahead and glued in the motor mounts. I did not use the fast activating accelerants for that part. I wanted to make sure they were fit just right. Checked the spacing and the angle and everything. They worked out quite nicely. Probably should have cut these cables a little shorter, but I'm going to cyano those with CA glue to the side here against the black tape here. That way it doesn't actually touch the wires. I'll make sure the shaft isn't touched either, so that'll get pulled to the side. I've gone and cut some of the foam here as well, so that I can fit the ESC right in there, and that should get proper airflow and keep it nice and cool. And then the channel, I haven't glued these wires in permanently yet, as we're going to test and make sure everything is the right length, but some of this might need trimmed out in order for the wire, or in order for the channel to go back in, the channel cover to go back in place. Next step here is to put the receiver in. The receiver is going to sit right about there where my finger is, and we need to feed the antenna wire down through that little tiny hole there, which then comes out the bottom and goes through the antenna tube out the tail of the plane. It might be easiest to take a thin wire, stick it through the tube all the way up to here, and then attach it to the receiver wire with some CA glue, a little drop of it, and pull it through. But one way or the other, we'll get it through. In feeding the receiver wire through the antenna wire, it was rather difficult. Could not use a clothes hanger because clothes hangers were too thick. So I ended up finding this nice piece of copper, fed it through, and then I used a tiny drop of CA glue on the other end to end, and now I'm pulling it right through with no problems. That's probably the best way to do it, right there. Here is a completed Dean's Y cable that was custom made by myself. This will go inside the fuselage. The male end will connect to the battery. These two ends will of course connect to the two male ends coming off of each ESC that I adapted. That way we can easily disconnect and reconnect from the wing using this Y adapter. Of course I could have just run those cables right towards the battery on one male adapter, skipping the Y, but I felt it would be easier to have an interconnect such as this. And I added some black tape just for extra reinforcement. It doesn't weigh too much, so it shouldn't hurt anything. You have to be careful that your negatives line up. And yes, you do wire 2 pair on each negative and positive on the male end of this cable. It was a little tricky, but I was able to get it done. And that is about it. Make sure you use a heat shrink underneath of there. And that is the Y cable. I also should note that gauge of wire is 16 gauge wire, which matches the gauge coming off the ESC. At this point I've used CA glue to glue the wires in place. This process was tricky because in the spar cover channel I had to etch out a lot of the inner edges of it in order for the wires to fit, because you need this spar cover to fit in here flush once it's pushed in place. And as you can see here, I etched out a lot of the sides, trying to leave the center channel as much intact as possible, taking out bigger chunks for where I have bunches of wires like here or here. Next I'm going to glue on the spar cover. Now that I've tested all the ailerons in a previous step undocumented here on this video, I basically plugged the battery and made sure everything was working. With this spar cover here, I'm not going to put glue down in here like it recommends. Simply going to get it down so it's flush, and then I'm going to put the glue all the way around the edges and then spray some activator, and that'll be perfectly fine because I've already done it here, as you can see. It worked out very well. At this point I've already done this part, but I have glued the wires into the recesses here on the side of the wing panels, ensuring that they're flush so that when we join the wings here together, it goes together nice and flush. And the next step is to put the wing spar bar through the wing panels, and I'll show the end result. We're coming to the final chapter of building the plane. As you can see, I have it all together now. I have the wing together. I just simply stuck the black spar through the wings, and I went ahead, put it on top, pushed all the wires in, connected everything up, and as you can see, the screws did very well. I screwed them in, not over tightening them too much because you don't want these things to break. And I also went ahead, turned the plane over earlier, and I measured back on the wing here. Measured back from the leading edge of the wing, that's towards the motors, 85 centimeters, and drew a dot. I went over and made a line under the belly of the plane. That was the center of gravity. That's where you place 2 of your fingers together and balance the plane, and the goal, of course, is to have the plane bounce. So in doing so, you may find that you need to shift the battery forward or back, or you need to move the receiver back further, or you need to add weight, possibly. At this point, the plane is coming in at 43.9 ounces. I think typically it's coming in around 43 ounces, depending on what type of battery you're using. Since I'm using the heavier battery, that makes sense. So 43.9 ounces using the scale. I did a crude thrust test using the same scale with the throttle at maximum, and I was getting roughly 43 ounces of thrust. I also hooked up the Astro Flight watt meter. As you can see, I put the leads on here, Dean's, soldered them on, and simply hook that between the battery, which I'll show you here under the canopy, between the battery and the Y adapter cable that we made, custom made. Just put that guy in the middle and then turn everything on. You can see the load, and you can see the load at maximum when you throttle it up the whole way. We'll actually see how it flies maybe in the next day or so, and I'm not going to paint it until after a test flight. I also have to go through and check all of the control surfaces for the proper elevation when you move them. The elevator, when it's up, in other words the stick back, should be plus 24 millimeters, and when it's down, stick forward, it should be 15 millimeters in the downward direction. The rudder going left should be 20 millimeters on either side. Ailerons should be up 18 millimeters and down 10 millimeters. You'll need to adjust, if you have a computerized radio, you'll need to adjust things on there using the flapper-on function. In this case, I've actually used both channels, so I could use the flapper-on ability. Later on, that means I can actually turn the ailerons into flaps with a single switch flick. If you don't use dual channels and use the Y cable, you won't have that ability. So I chose to suck up an extra channel, so in essence I'm using 5 channels. And that is about it. I still have to Velcro in the battery and the receiver in their final positions once I'm sure of it. And I have to add some CA to the bolts on each of the control horns once I'm sure they're exactly the way I want them. If you don't have a computerized radio, getting those plus 24 millimeters and minus 15 millimeters and so forth, you'll have to actually adjust the horns, I believe, and the control surfaces until you reach the desired effect. Most people do have computerized radios such as this one, which allows for easy adjustment. And that is it for right now. Oh, when I test the RPMs with these motors, RPMs are coming in at approximately 80 to 22. 8,222 RPMs on each motor, giving it a combined 16,444, which is pretty good. I think my older Zaggy comes in at around 14,000 RPMs on a single motor and a 28-ounce plane. So for a 43.9-ounce plane, we'll see how it flies. I should also mention in this case I had trouble with servo groan at the maximum positions on the stick. You would hear the servos groaning. I don't have it plugged in right now to demonstrate that. You should try to eliminate that if you can. One of the suggestions was to actually take the control horn on the servo itself and move that in a notch prior to moving the actual control surface. That didn't really work for me, and you're actually okay with servo groan as long as they're within the limits. They're not binding anywhere physically. It's probably not a problem. You can also try adjusting the ATV. I had to take mine all the way down to 25% to eliminate the groan completely, so that wasn't acceptable. So I'm living with the servo groan in this case, which I don't think is going to draw too many extra amps or drain the battery irregularly, so it should be fine. I also still have to take the props off of here and balance them. I did a crude balance check earlier, just using a simple finger balancer and 2 plywood blocks. Here, as you can see, I'll demonstrate. Simply slide the propeller onto the balancer, tighten it up, place it between, say, 2 blocks that are level, and let it go. As you can see, it's dipping to the left. That means the left side is heavy, so what I'll have to do is take some sandpaper and lightly sand the left surface gradually until the whole thing is balanced. Now calibrating the ailerons. I have measured the lengths. When the stick is pushed to the right aileron should go up. When the stick is pushed to the left aileron should go up. Again, that's 18 millimeters up and 10 millimeters down. I now did the elevator. The elevator should go up 24 millimeters. So using the ruler, I leveled it off and then went up. Make sure it was 24 meters. Adjust the ATV on the transmitter until it's at 24 millimeters. Then I went in the other direction, going down, and I made sure that that was at plus 15 millimeters. Doing the rudder now, 20 millimeters in each direction. As you can see, I center it, swing it in each direction. Adjust the ATV as necessary. And don't forget, again, put a drop of CA glue on that nut when everything is tight and ready to roll. The Twinstar video we're looking at here is a tote for carrying electronics and your chargers out to the field. And what I've chosen to do here is use my Cell Pro 4. That's the type of charger I'm using. It's a balancer charger. It comes with alligator clips, but what I've done is gone and put banana plugs on the other end and taken off the alligator clips. This unit has an on-off switch, which is kind of nice. It has 2 input jacks, so you can charge your batteries that might be inside, or power your PSU if you put a PSU inside. As you can see, it has ample space, though very little drawer space, so you're left with an open canopy type setup. And your transmitter can sit right here, which mine will. The drawer that it came with, I've kind of been modifying it here. We're going to use this drawer for charging the LiPo batteries. And since I only have 2, and at most we could have 2 chargers running off of this at once, I'm going to use this drawer to charge 3200 milliamp hour battery packs, which should fit just fine in here, two at once, sideways. Leads coming through this opening here is the ventilation as well. Now what I'm going to do is I've taken some balsa wood and I'm making a lid for it. I made the lid so it fits down inside of the box flush with the top, because there's no room to lay the lid on top. You have to actually have it down inside and flush, cut the notches out and so forth so it fits. And on the other side I'm putting this standard high temperature flue tape that I got at the hardware store, covering it up. This is good to up to 600 degrees Fahrenheit. So I'm going to cover up the wood with this, and once that's covered up I'll glue that onto the box like that. Of course, first I'm going to do the inside of the box with the same material. Flue tape inside of the box, flue tape on the back door. This will be the way we get in and out. And then once the lid's in place, glue that on. We'll have the flap back here with a simple, probably piece of tape to be able to open and close and put the batteries in. I will not charge these batteries inside of the tote. I will simply remove the drawer and have I got a 3-foot extension cable that you can get from FMA Direct to extend the battery charging lead out to wherever you want to go, excuse me. So both at home and on the field I will simply remove the drawer from here, just acting as a storage carrying device, and that becomes a charging box, 600 degree Fahrenheit protected inside of the box. There are other methods you could use to charge if you want to carry separate things. You could use something called a LiPo sack that's about 30 bucks on the internet. You could use a Pyrex bowl. You can line it with the same type of flue tape if you want. You could use a simple flower pot, one of those clay varieties, which would work just as well. The batteries I have inside of this tote are 7 amp hour batteries, which can be charged with the standard AC wall adapter. This one is 600 amp hour, 600 milliamp output. It's a little under 1C for a 7 amp battery, I believe. And on the other end, I put the banana jack so that could be plugged into the front of the tote. But with these type of wall adapters, despite what you might hear, you do have to be careful because you can cook the battery, despite what some people seem to think. So what I've gone and done is went online and bought a float charger from Harbor Freight, and it will automatically shut off at the end of a cycle of charging once it's done. That is the advantage of a float charger. So it would be a good idea, unless you plan on checking voltages, to get a float charger to make sure the batteries are not being cooked. That way too I can leave it plugged in all the time at home with the float charger, and I can plug in my Servo at the same time and safely charge my battery packs at the same time, knowing that the battery pack will always be full when I go out to the field. So I'll have power in these 12-volt batteries to charge maybe per each one, maybe twice on a 3200 milliamp hour battery pack. I might get 4 charges with 2 of these batteries in here. You could probably fit a 20 amp hour battery in here. Take these 2 out and put it in sideways, laying down. It might stick out maybe a 1/4 of an inch, and you could probably get away with that with some way of securing it from coming out. It normally comes with this box, which I think you're supposed to put the batteries in, but I've secured at least this one with a Velcro tab here, so it ain't going anywhere. This guy I'm using just to store my transmitter in, because normally I don't have the second battery in there. I'm just charging it up right now, so that would go in there and store the voltmeter. I think I said transmitter, but the voltmeter goes in that box. And when you're not using the tote, you could always just throw a piece of plastic over top of over the tote to keep it from getting dirty, or your transmitter from getting dirty, if you choose to keep your transmitter there. There's another brand out there called Electro Tote, all one word. Pretty good box. It's a lot bigger than this. It's made out of wood and metal. It has a fan and a lot of drawers for storage, so if you don't mind the extra length and the size vertically, the Electro Tote is another good alternative. Again, this one supports up to 2 chargers. So I've got the Servo here, and this one is officially for the Triton Junior, so I might throw a Triton Junior and an Electrify balancer with that as well. So that is the tote, and I'll modify this box so it can be charging LiPos safely indoors and outdoors. And showing you here the final product of the LiPo safe storage container, or charging container I guess we'll call it. As you can see, I've made a hole in the front to let the charge lead come through. The inside is completely insulated with a 600-degree tin. Outside flap. It may look crude, but it'll be effective. Key here to remember again with LiPos is you always should charge them in a fire-safe device, even at 1C, especially indoors. Never charge LiPos in a vehicle. Always use either a cigarette lighter adapter to the outside of the vehicle or connected to your car's battery, or use an e-tote such as this one, an e-box such as this one, with its own onboard battery, and you can charge like I'm going to do in this fashion. As you can see, I had to make some modifications. It was a little too wide and too tall to fit in there, so I sanded it down. So now it should fit just right. And there we go. You can go in further, but I just put it in that far for now. I can easily remove it through the small hole here, the charge lead hole. And that's it. That's the way to transport it. Take it out when you want to charge, indoor and outdoor. I've now reached the pre-painting stage, and what I've gone and done is I have masked off the areas where I don't want the first spraying to go on. Especially in this middle section here, we don't want to have any paint in the grooves where the wings go together. It could cause problems. We also don't want the wires to get covered in paint, so that'll get taped over a little bit better there. Of course, the nacelles are taped over. Basically, this wing here is going to be completely black, and the areas that are taped off will be yellow, which I will use. I will use the Krylon spray on the black area. For those yellow sections, I'm going to use the it's called, let me find it here and show you what it is. It's Folk Art acrylic paint found at Michael's store. Quite handy. May actually be more durable than the Krylon, but we'll have to see. And we also want to make sure that, like, areas where the servos are, that the spray or the paint can't get down in the grooves there as well. Plus, that reduces any extra weight that would be added to the plane unnecessarily. I've also gone and taped off the hinges section, like in this crack here. There's tape separating the hinge so it doesn't get filled with paint. Prevent the hinges from getting fused in some way with hard paint. Same thing here on the top side. This is going to be spray painted yellow with black on the nacelles up here. And the wing panel where the screws go down through and the fasteners, I've put tape in there to keep the paint out of there as well. And that is the wing section. Finally, here's the fuselage section. I've taped off the top half and left the bottom half exposed for right now. Bottom half will be spray painted black, and the tail section will be spray painted black as well, at least the rudder area. And this area will be saved for yellow to match the wing section. And on the bottom side, of course, is black, and down here is black, and that's going to be yellow to match the underside of the wing section, which are going to have yellow on the ailerons there, yellow on the elevators here. And that is about it. So I will spray paint. On the next segment you'll see the result. Spray painting best done, of course, in a well ventilated area or outside if it's not windy. And of course, hand painting, you can do that anywhere. Just showing a modified box for carrying the plane. I know it's kind of cheesy, but it's very effective. I have put some packing material around the outer edges. Not too worried about the inner edges, it's more about the outer edges. With the exception of the tail section, which is kind of hard to see here. But as you can see, it's pretty well snug, even with a diagonal kind of sliding in effect there. I've cut a notch in the top to prevent any pressure. And I've modified a transmitter strap to use as a carrying case strap. Simple strap here. Cheesy, but somewhat effective. Keeps things from bouncing into it in the trunk of a car in a fairly small area. Okay, we can now see the final version of the plane's colors. I haven't bothered to really tidy up any of the edging on here yet. I may not even worry about it. The wing is not fully attached either, it's just sitting there, as you can tell. I ended up using the acrylic yellow because the spray paint yellow was a different shade. I ended up liking the acrylic better. A 2-ounce acrylic bottle times about 2 for black, and then yellow would probably have been more than enough of the 2 fluid ounce containers, so 4 fluid ounces at the most, but probably not even 3/4 of that. The total weight of the plane is now at 45.2 ounces. It was 44.2, so it gained about an ounce due to painting. And the masking worked rather well, and using the paintbrushes for the acrylic was pretty easy to go around the edges. And finally, I adjusted the canopy tongues so that now it's very secure. Highly doubt that would come loose in flight. Simply have to push forward and then up with 2 hands. One hand doesn't quite work, so as you can see it's pretty tight. And there's the final positioning of the tongues. Works really well from that position. You can get an idea of the height above the foam. That is what worked really well. And that's a wrap. That's the plane. Sorry about the bad lighting on this last few shots here. It's the most wide open spot I had. And that's a wrap on the Twinstar II brushless design and guide.